In this calculus 2 example, we are asked to consider the integral, and then we are given the integral right here. And for part A, for what values in the interval 0 to 1 is x ln x undefined. And then for part B, we need to evaluate the integral. When we look at this problem, we can solve it by graphing. When we have an x, we know that an x is just going to be like this, depending on what number is plugged into it. For an ln of x, we know that the graph looks something a little bit more like this. And we know that this side right here goes on to infinity. However, since we have an upper bound of 1, it is capped at 1. So this is not the problem. What is the problem though, what is undefined, is this 0 part right here. Because although our graph right here comes close, it never touches the y-axis. So when it asks us for what values in the interval 0 to 1 is x ln x undefined, that means the only value here is 0. And 0 is undefined because ln of x comes close but does not touch 0. And this will be our answer for part A. For part B, we are asked to evaluate the integral. So I just copied the integral down here, and now we can start evaluating it. Before we evaluate it, we need to actually rewrite this, because this is improper, because we have a part that's undefined. We need to have a limit that represents this, so we're going to write this out with the limit n is equal to 0. Then we are going to have our integral, but instead of 0 down here, we are going to have an n. That way we can actually solve it. And now we can write out our x, ln of x, d of x. For this specific problem, we need to solve this by parts. So we can write our by parts for this, and we know that in by parts, we have an a, b brace right here, which is going to represent our integral, or integration, and then we're going to have a negative integral, and then our b, d of a. We know that our a for this problem is going to have to be ln of x, because we can't integrate ln of x. We will have a is equal to ln x. That means d of a is going to be the derivative of it, which is 1 over x dx. For db, we are just going to have x d of x, and then when we take the integral of this, for b, we are going to have x squared divided by 2. So we're going to rewrite this. Again, remember that this part is going to be equal to this right here, because it is by parts. So now rewriting this, we have our a, which is ln of x, being multiplied by our b, which is x squared divided by 2. And then we have our bracket right here with a 1 and an n. This actually should all be surrounded by the limit. We will have an outside bracket, and this will be the limit of n is going to 0. And then we have our negative right here, the integral from n to 1, and then our b, which is x squared over 2, times our d, which is 1 over x d of x. We're going to close this, and this is our equation right now. Inside of here, the integral part, we can simplify this, and then we can actually take the integral of it. So we will rewrite this. The first part is going to be the same. The only thing that's changing is in the integral. We can move our 1/2 out front, and then that way inside of here we are just going to be left with an x dx. We can close this off, and now we can start substituting in and solving. So when we look at this, we're going to solve it by parts. So we are going to do this part, and then we will look at this part. In red, the first thing that we have is this 1 right here. Well, when we plug in our 1 to our ln, it's going to be 0. So initially, everything is going to be 0 for the first part. That means we're going to have a 0 here. We'll have a minus. Plugging in our n for x's, we will have an ln n, and then an n squared divided by 2 minus a 1/2. So this is the part in blue, and then the integral of this, which is just x squared divided by 2. And then we have our 1 and n right here. We need to solve this last part, so we're going to have to rewrite it again. I'm going to factor out the 2 from inside, so we're going to have a negative 1/4, and then our x squared, which is just going to be 1, so we're going to have a 1 in here, minus an n squared. So this is our problem, and now we can start plugging this n is equal to 0 inside, at least for this part right here. When we plug it in for this part, we can include this negative in here as well. So we will have a negative 1/4, and then we have a 1 minus n squared, which will be 0. So this is going to give us a constant. This is going to give us negative 1 over 4th. So this part is fine right here. The only issue, we'll do it in red, is this part, because ln of 0 does not exist. I did make an error that I corrected right here, a little bit too late though. When we write this, it's important to write that the limit is not n is equal to 0, but that n is approaching 0. If it's equal to 0, we still can't solve this problem, but if it's approaching 0, we can solve this problem. So we have to change all of these to approaching 0. N is approaching 0, not equal to 0. Now, if we write that out, we can plug this in as the limit as n approaching 0, and then what we had here. We'll just get rid of the 0, and we'll focus on the negative ln of n squared divided by 2. And then we have our minus 1/4 over here. When n is approaching 0, because this is approaching, when n is approaching 0, our ln of x graph is getting super small. So if I graph it like this, and we look at this part right here, because this is where n is approaching 0, it gets super small. And this n squared right here is 0. So we can assume that this is basically 0. It's almost 0. It's so small, it's so close, it's almost 0. So we can zero this out. And if this is also 0, we have basically a 0 times a 0. So that means this entire part is going to be approaching 0. That means for this answer, when it's asking us to evaluate the integral, our answer is going to have to be just negative 1 over 4, because that's all that's left. So that is our answer. For part A, in number 5, we said it's undefined because 0 is included in this, and ln of x never touches 0. For part B, when we evaluate it, we have to set a limit out front, n is approaching 0, and then we substitute the 0 for n. Then we do a by parts. We do all of this work. This is all by parts work until we get down to this step right here, where we plug in our n for this side and we get negative 1/4. After we get negative 1/4 here, we say that our n is approaching 0, and we can see that this is approximately, basically, 0. We can assume that it's 0, and so all we're left with is a negative 1/4. That means our answer is negative 1 over 4. And that is all the work required to consider this integral, see which part of it is undefined, and then evaluate it.